Okay guys, so this lesson here is about solving absolute value inequalities. You saw absolute value equations, now inequalities, where the main difference is that when you write the negative equation, because you remember you're going to write two equations, when you write the negative one, you got to also flip the symbol. So we're using this, still going to isolate, rewrite, solve, isolate the absolute value, rewrite two equations, solve both, get two answers. Still using the DCMAM steps. You can throw the L in there also for the line. And then again, when you rewrite two equations, you have to flip the symbol for the negative equation. So one more thing is with these absolute value equations, if they start out with a greater than sign or greater than equal to, think of it as great or. Again, if it has a greater than symbol, think of it as great or, because it should have the word or in it. If it has the less than or equal to symbol, think of it as less than. Again, if it has the less than or equal to symbol from the beginning, think less than, because it should be an inequality that uses the word and. So look at this one. The absolute value of 8n is greater than or equal to 4. So that's, in my mind, that is great or. Again, the reason I think great or is because it should use the word or. So remember, once the absolute value is isolated, which it's already isolated, you can rewrite as two inequalities, again using the word or because it's greater, so great or. When you rewrite the second one, you rewrite it as a negative 24, but you also have to flip the symbol. That is the one new thing in these types of problems. You not only do you have to make one positive and one negative equation, but you have to flip the symbol also on the negative one. So now let's solve this. Divide by 8. I get n is greater than or equal to 3. And then here, same thing, right? Same step for solving, but different answer. Negative 24 divided by 8 is negative 3. So n is greater than or equal to 3, or n is less than or equal to negative 3. And then graphing, guys, of course I need a circle at negative 3 and positive 3. And they both should be shaded. At positive 3, right? At positive 3, shaded circle, greater than, meaning point or shade right. At negative 3, a shaded circle, but it says less than or equal to, so the numbers that are less than are on the left. So at negative 3, this tells me shade left. And again, at positive 3, the symbol tells me to shade to the right. So if I can get this far to get my answer, I just got to pay attention to the number here. Symbol tells me which way to shade and whether it's an open or shaded circle. So careful with that, right? Make sure you look at the number, and then the symbol tells you what to do when you're at that number. This next one, the absolute value is already isolated, so I'm going to rewrite as 1 positive, meaning 3p plus 9 is less than 24. And since it says less than, it's less than, so it's using the word and. And when I rewrite the second one, 3p plus 9 is greater than, you got to flip it and make that a negative 24. Now solve both. So solving this, right, I'm going to subtract 9, and then I get 3p is less than 24 minus 9 is 15, and then divide both sides by 3. So this one has a solution of p is less than 5. And then this one, same steps, different answer though, right? I'll still subtract 9 and divide by 3, but I won't get the same answer. So subtract 9. 3p is greater than negative 33. Divide both sides by 3. And I get p is greater than negative 11. So there's my answers, and is part of the answer. Graphing it, right? Remember, at 5, it's greater than, so that's a shaded circle, or sorry, it's p is less than 5. At 5, it's less than, so 0, put 5 over here, and it should be an open circle. Less than means point that way. And then this one, p is greater than negative 11, so at negative 11, open circle, and then greater than means point to the right. So again, using the word, oh my bad you guys, this is a greater than symbol, so I should think, or no, okay, so let me back it up. Less than, so less than, okay, we're good. So I'll make sure I get it right. The next one is not isolated, you guys, so I'll have to add 4 to isolate. Remember, this is the absolute value. I need to isolate it, so I'm adding 4, and I'm getting 4 cancels out. 8 plus 4 is 12. Then I get the absolute value of x minus 9 is greater than or equal to 8 plus 4 is 12. Okay guys, so my video got a little messed up, but as you can see here, it started out with greater than, so remember greater than, we say great or, that we remember that this should have the word or in it. I rewrote it as x minus 9 is greater than or equal to 12, and x minus 9 is less than or equal to negative 12. So now I'm going to add 9, and 12 plus 9 is 21, so this one will have a solution, x is greater than or equal to 21, and this one I'll add 9, and I'll get a solution of x is less than or equal to negative 3. So it's, there's my 2 answers. Sorry, there's not a lot of room here. Should have the word or, and then graphing this, right? Remember, the word or is used when, basically, when there's 2 conditions that are kind of separate, so these should definitely be separate. So at negative 3, I should have, it's less than or equal, I should have a shaded circle pointing left, or shaded left if you like. At 21, greater than or equal to 21, I should have a shaded circle pointing right. So again, you're seeing here why greater is greater, because it always ends up with these separate conditions, and less than is going to be less than, because whenever it's a less than symbol, it always ends up being conditions where both conditions need to be met. So this one says less than. I'm definitely going to use the word and. Right now I'm isolating the absolute value, divide by 8. Absolute value is now isolated. Absolute value of x plus 6 is less than 1, because 8 divided by 8 is 1. Now it's isolated. I'm ready to rewrite as 2 inequalities. X, 1 positive, 1 negative. Don't forget to flip the symbol on the negative one. So x plus 6 is less than 1, and x plus 6 is greater than negative 1. Solving both of these, I would subtract 6 to solve. So I'd get x is less than negative 5, and then when I rewrite, or sorry, when I solve this one, right, same step, subtract 6, different answer. I get x is greater than negative 7, so x has to be less than negative 5, but greater than negative 7. So graphing this, right, let's see, let's put 0, put a negative 5, put a negative 7. So remember, at negative 5, it's less than, so open circle at negative 5, point left. At negative 7, x is greater than negative 7, so open circle pointing right. And that's how you do those. So there you go. So these last few, I'm going to go ahead and try to get through these quickly. This symbol is greater, so great or, meaning x plus 7 is greater than or equal to 11. Remember, the absolute value is already isolated, so I can just rewrite my 2 inequalities. X plus 7 is greater than or equal to 11, or x plus 7 is less than or equal to negative 11. Solving this, all I got to do is subtract 7, so I get x is greater than or equal to 4. And here, when I subtract 7, I get x is less than or equal to negative 18. So there's our answer. Graphing this looks like this. At 4, At 4, I should have a shaded circle pointing right. And at negative 18, less than or equal to negative 18, so I should have negative 18, I should have a shaded circle point left, as it said less than, so there's that. I'm going to keep going, guys. Again, here the absolute value is already isolated. It does say less than, so that's less than, again, to remind me to use the word and. So x plus 5 is less than 3. Right? 2 inequalities, one positive, one negative. Don't forget to flip the symbol on the negative one, so the negative one should say x plus 5 is greater than negative 3. Solving both of these, right, I would subtract 5, so I get x is 3 minus 5 is negative 2. So x is like less than negative 2, and this side when I subtract 5, I get x is greater than negative 8. So there's my answer. And then graphing this, I have negative 2, negative 8, open circles at both. They should be connected. Think about it. At negative 2, it's less than, so point left. At negative 8, it's greater than, so point right. And then you see it's 2 circles connecting like it should be for a and inequality. I'm going to keep going here, guys. Almost through this. Just going to do these last couple problems. On this one, I have to add 6 to isolate the absolute value. Adding 6 isolates the absolute value. Get 7 there, and now I'm ready to rewrite as x minus 4 is greater than 7. It was a greater than symbol, so it should use the word or. Great or, remember, the original symbol. So x minus 4 is greater than 7, or x minus 4 is less. Got to flip the symbol and make the number negative. Solving this, all I have to do is add 4. So I get x is greater than 11, and on this next one, when I add 4, I get x is less than negative 7 plus 4 is negative 3. So there's my answer, my solution, right? And if I graph my solution, well, here's what it looks like. It's at, let's see, at, whoops, that should have been just a line. At 11, I should have an open circle, right? At 11, greater than, so open circle, and it's greater than, so it should point right. At negative 3, I should have, oh, guys, it should be an open circle. Sorry about that. This circle should be open, not shaded. Same thing at negative 3. It should be an open circle and less than, so point left at negative 3. So there's your graph again. These should both be open circles. Sorry about that. This last one here, I can solve by first isolating the absolute value. I'm going to have to subtract 4 to do that. And I got the absolute value of negative 6x is less than or equal to 24. Now that the absolute value is isolated, I can rewrite as 2 equations. So I'm going to get negative 6x is less than or equal to 24. Remember, the original symbol tells me whether it should say and or. It was less than, so remember less than is like less than. So use the word and your second inequality should say negative 6x is greater than or equal to negative 24. When you solve these, you divide by 6. Oh, actually, you divide by negative 6, so this one has an extra step. When you divide by negative 6, you have to flip that little symbol. So divide both sides by a negative number, you got to flip that. So I'm going to flip it. 24 divided by negative 6 is negative 4. This one down here, when I divide by negative 6, same thing. I got to flip that symbol. So x is going to be less than or equal to negative 24 divided by negative 6 is a positive 4. So there's my 2 inequalities. And if I graph these, it's greater than or equal to negative 4, less than or equal to positive 4. So it should be shaded circles at negative 4 and 4, and they should be connecting, because again, it's greater than or equal to negative 4, but less than or equal to 4. So there's the graph of the solution.